Have you ever stopped to wonder why a whiteboard works so differently from an ordinary wall or a sheet of paper? You can write on it, wipe it clean in seconds, and repeat the process thousands of times without leaving much behind. Whether it's in classrooms, offices, hospitals, or even kitchens, the humble whiteboard has become one of the most useful tools for sharing ideas. Yet behind its smooth white surface is a surprisingly clever combination of engineering, chemistry, and manufacturing. The secret isn't just the marker or the eraser, it's the carefully designed surface that allows ink to sit on top instead of soaking in. Every layer, from the sturdy backing to the glossy coating, plays an important role in making the board durable, easy to clean, and resistant to stains. So what gives them that slippery surface that keeps dry erase ink from sticking? Let's find out right here on History of Simple Things. Although a whiteboard appears to be a simple flat panel, it actually begins with a solid foundation called the substrate, or core. This is the material that gives the board its strength and keeps it from bending. For many everyday whiteboards, manufacturers use medium-density fiber board, commonly known as MDF. This engineered wood is smooth, affordable, and stable, making it an ideal base. Higher-end whiteboards, especially those found in schools and conference rooms, often use steel or aluminum sheets instead. Steel offers the added benefit of allowing magnets to stick to the board, which is why magnetic whiteboards are so common. The chosen material is cut into precise dimensions using industrial saws or laser-guided cutting machines. The edges are trimmed to ensure the board is perfectly square before moving on to the next stage. At this point, the board is still just a plain panel. The smooth writing surface hasn't been added yet. The white surface itself can be made in several different ways, depending on the quality and intended use of the whiteboard. The most affordable whiteboards use a laminated surface. A thin sheet of melamine, a durable plastic resin, is bonded to the core using heat and pressure. The result is a glossy white finish that is inexpensive to produce and suitable for light everyday use. More premium whiteboards use porcelain enamel. In this process, powdered glass is fused onto a steel sheet inside a furnace at temperatures exceeding 800 degrees Celsius. As the glass melts, it permanently bonds with the steel, creating an incredibly hard, scratch-resistant surface that can last for decades. Regardless of the material, every surface must be exceptionally smooth. Even microscopic imperfections can trap tiny particles of ink, making the board harder to erase over time. What really makes a whiteboard special is its outermost coating. At first glance, it might seem like dry erase markers simply contain magical ink that wipes away easily. In reality, the whiteboard surface is doing most of the work. Manufacturers apply an extremely smooth, chemically resistant finish made from specialized polymers or glass-like coatings. These materials have very low surface energy, meaning liquids don't spread out and cling tightly to them. Instead of soaking into the board, the ink stays on the surface as a very thin film. Dry erase markers are also specially designed for this type of surface. Their ink contains pigments mixed with alcohol-based solvents and silicone polymers. When you write, the solvent quickly evaporates, leaving behind a flexible plastic-like layer of pigment resting on top of the board instead of bonding with it. Because the board's coating is chemically non-porous and exceptionally slick, there are very few places for the pigment to grab onto. When you wipe the surface with an eraser, friction simply lifts that thin layer away. This is also why permanent markers behave so differently. Their solvents are formulated to chemically bond with many surfaces, allowing the ink to penetrate tiny imperfections and making it much more difficult to remove. In other words, it's not just the marker that makes dry erasing possible. It's the partnership between specially formulated ink and an incredibly smooth chemical coating. Most whiteboards receive an aluminum frame around the edges. The frame protects the corners from impacts, keeps the panel rigid, and provides mounting points for installation. Rubber corner caps are often added to improve safety, while also giving the board a finished appearance. Many models include a marker tray, usually made from aluminum or molded plastic, which is attached to the bottom edge. Although these components seem minor, they greatly improve the board's everyday usability. Even high-quality whiteboards don't stay perfect forever. Over time, tiny scratches caused by abrasive cleaners, dirty erasers, or excessive pressure gradually roughen the surface. These microscopic grooves trap pigments that become increasingly difficult to remove. Another common problem is ghosting, the faint shadows of old writing that remain after erasing. Ghosting happens because minute amounts of pigment slowly accumulate inside these tiny imperfections, or because marker residue builds up over repeated use. Cheap melamine boards are especially prone to this because their softer surface wears down much faster than porcelain enamel. Leaving writing on the board for weeks or months can also make stains harder to remove, as some components of the ink slowly interact with the surface over time. That's why manufacturers recommend using proper dry erase cleaners and soft microfiber cloths instead of abrasive household cleaners. Whiteboards may look ordinary, but they're the result of clever material science and precise manufacturing. From sturdy wooden or steel cores to carefully bonded surfaces and chemically engineered coatings, every layer has a specific purpose. Perhaps the most fascinating part is the invisible chemistry happening every time you write. The slick, non-porous coating prevents dry erase ink from forming a strong bond, allowing it to sit on the surface until a simple wipe removes it. It's a perfect example of how the right combination of materials can solve an everyday problem in an elegant way. So the next time you jot down a reminder, sketch an idea, or solve a difficult equation on a whiteboard, you'll know that beneath that glossy surface is decades of innovation in chemistry, engineering, and manufacturing, all working together to make writing disappear with just one swipe. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.